Hello, and welcome to the lesson on expressions, equations, formula, and identity. What are we going to learn in this lesson? First, we are going to understand what does each of these quantity means: expression, equations, formula, and identity. Then we'll try and understand the differences between each of these quantities. And finally, we'll look at some of the examples of each of them. So let's get started then. We have learned about algebraic expressions in one of the previous lessons. You may watch that video if you want. An algebraic expression is a group of terms which are separated by a plus or a minus sign. The important thing is an expression doesn't have an equal to sign and hence it cannot be solved. So these are the examples of algebraic expressions: 5x, 3x plus 2y, 6x plus 4y minus 3. All of these are algebraic expressions. An algebraic expression can be classified on the basis of 1. Number of terms, and 2. The degree. Now, what are each of these? As you know, term is nothing but a basic unit of algebra, consists of one of the following, okay, which means it consists of one of the following: a number, it could be 5, 12, minus 3, and minus 10, a variable like an x, y, a, or m, or any combination of a coefficient and a variable multiplied or divided by each other. Remember, the coefficient is the number which is multiplied to the variable, like a 5x, 3y, xy, 7xy, 8x over y. Now, I just rushed through this because we have done this or covered this in one of the lessons previously. But the more important thing is, how are algebraic expressions classified on the basis of terms? Well, depending on the number of terms, an algebraic expression can be, okay, so if it is one term, it is called a monomial. For example, 7x, 4y, 6xy. All of these are expressions having exactly one term, and hence each one of them is a monomial. A binomial is an algebraic expression having two terms, like a 5x plus 2y, right? So 5x is one term, 2x is other one. And this is an algebraic expression because we have two terms separated by a plus sign. Likewise, 3y minus 7 is also an example of a binomial. A trinomial is an example of an expression, an algebraic expression having three terms. So 4x plus y plus z is a trinomial. 5y minus 2m plus 3 is a trinomial. Whereas if an algebraic expression has more than three terms, then it is generally called a polynomial. How are the algebraic expressions classified depending on the degree of an expression? First of all, what is a degree? A degree is the highest power of any term in an expression. For example, okay, if a term contains more than one variable, then their net power is considered, which means we add the powers. Because if there are more than one power, if they are multiplied, we add the powers. If they are divided, we subtract the powers, right? Use the laws of indices. So in this case, if you look at it, this is a binomial. 6x cubed minus 9y to the power of 5. So the first term has a degree of 3 because the variable has a power of 3, whereas the second term has a degree of 5 because the second term, the variable is raised to a power of 5. So this algebraic expression has a degree of 5 because 5 is the highest power of the variable which is present in this particular expression. Let's look at one more example. 2x squared y squared plus 3x cubed minus 7x. So this is a trinomial because it has three terms. The degree of the first term is 4 because x is raised to a power of 2 and y is raised to a power of 2. And because they are multiplied, the combined power is 4. Remember, if there are more than one variables, then their net power needs to be considered. The second term is 3x cubed. It has a degree of 3 because x is raised to a power of 3. And the third term is 7x. It has a degree of 1 because x is raised to a power of 1. So together as an expression, that the highest power which is contained in any term is 4, and hence this particular expression has a degree of 4. So how are algebraic expression classified based on the degree? So the degree could be 1, 2, 3, or more than 3. If an expression has a degree of 1, it is called a linear expression. So a 7x, 5x plus 2y, 3y minus 7 are all examples of linear expression, because if you see, the variables are raised to a power of 1 in each of these cases. So the degree is 1. If an expression has a degree of 2, it is called a quadratic expression. So 5x squared plus 2y, or x squared minus 7x plus 2, or simply xy. Remember, even in xy, although it might look like a linear expression because x is raised to a power of 1, y is raised to a power of 1, but because they are multiplied, the combined power of the expression is 2. And hence, it's not linear, it's a quadratic expression. When the degree of the expression is 3, it's called a cubic expression. Examples of cubic expressions are 4x cubed plus 5, 2x cubed minus 5x squared plus x squared plus 1, or simply x, y, z. Because each of x, y, and z have powers of 1 and they are multiplied. So the combined power of that expression is 3. If the degree of any expression is more than 3, then it is generally called a higher order expression. For example, 3x to the power 4 plus 2, 3x to the power 5 minus 5x cubed plus 2x plus 6, or simply x squared y cubed. All of these are examples of higher order algebraic expressions. So these are algebraic expressions. So what is an equation? An equation is simply a mathematical statement that shows that two expressions are equal. So if I equate the two expressions, that becomes an equation. Like 5x equals to 20, 3x plus 2y equals to 25, 6x plus 4y equals to 2x minus y. So all of these are examples of equations. Now, like algebraic expressions, equations are also classified based on the degree of the expressions that are equated. So we can have a linear equation where a linear expression is equated to something like a 5x plus 3, which is a linear expression equated to 38. We can have a quadratic equation where a quadratic expression is equated to something like a 2x squared plus 5x plus 7, which is a quadratic expression equated to 10. And, and again, okay, it's like in case of expression, we can have a cubic equation where a cubic expression like a 4x cubed plus 2x squared plus 3x plus 4 is equated to 6. So we have understood what are expressions and equations. What are identities? Well, identities are equations which are always true no matter what values of the variables are chosen. Right? These are equations which are always true. An identity is represented by three lines, okay, as against two lines in case of an equation. So if it is an identity, we represent it by three lines. Okay, so examples of identity are x plus y and y plus x. As you know, x plus y will always be the same as y plus x. Even if I change the order of the terms, it represents the same thing. And hence, it's an identity. X plus x, which is the same as 2x, right? So x plus x and 2x are identities. And hence, they are separated by three lines, as you can see. Finally, let's come to formula. What is a formula? Formula is an equation which is used to represent a rule in which symbols have set meanings. Okay, so each of those symbols that are used or variables that are used represent a specific quantity. It has meanings. For example, S equals to D times T, where S represents speed, D represents distance, and T represents time. So speed equals to distance times time. That's a formula. A equals to L times W. Now, this is something which most of you are familiar with, right? A is the area, L is length, and W is width. So in case of a rectangle, remember, area is given by length times width. So A equals to L times W. So that's a formula, right? So you may get confused between an equation, an identity, and a formula. But an equation is simply an expression equated to something. An identity is a special kind of equation where the left-hand side and the right-hand side of the equation are always equal. Whereas a formula is again a special type of equation where each of those symbols used in the equation refer to specific quantities and they have some meanings, right? Let's revise each of those four quantities that we learned. Okay, all you need to do is read the statements which are given and try to find out which of the four quantities, okay, identity, formula, expression, or equation goes well with each of these statements. You may pause the video at this moment if you want and take this exercise. The first one, when two sides are always equal, right? Irrespective of the value of the variable, left hand side and right hand side are always equal. What do we call that? An identity, correct? Well done. When there is no equal to sign, okay, if there is no equal to sign, it means it's simply an expression, right? It's not an equation or an identity or a formula. When you solve to find the value of the letter, that's clearly an equation, because in an equation you can solve and find the value of the unknown. A rule which with symbols representing a physical quantity. Well, you know that's a formula, because each of those letter represents some quantity. They have specific meanings. When three lines are used instead of two lines, okay, two lines as equations, so three lines should be, well, you know that it's an identity. And what about the last one? When two expressions are equated, okay, when generally two expressions are equated without anything specific, it's a equation, right? It's an equation. Right. Here's one more exercise just to revise what we learned. You need to classify each of these into expressions, equations, identity, and formula. Correct? Now, just to make it a little tricky, we have not represented identity with three lines. We have represented identity with two lines, because otherwise it would become more obvious, right? To identify identities. So go on. You may choose to pause the video once again and try to take this exercise and let us know what do you think is each of these quantities. Is it an expression? If it's an expression, write an E. If it's an equation, represent that with a Q. For identity, represent it with I. And for formula, you can represent that with an F. Let's start. What is 7x? Well, it has no equal to sign. Clearly, that's an expression. So E. 3x plus 2 equals to 29. There's an equal to sign, so it has to be an equation, identity, or a formula. But because left hand side and right hand side are not always equal, okay, it depends on the value of x, and the x doesn't represent a particular quantity, it's an equation and not an identity or a formula. So Q. Next, 6x minus 2x equals to 4x. As you know, left hand side is 6x minus 2x, which is 4x, and right hand side is 4x, which means irrespective of the value of x, the left hand side and the right hand side will always be equal, and hence that's an example of an identity. What about F equals to m times a? Now you know its force equals to mass times the acceleration. If you've learned it in science, then that qualifies as a formula. So F. What about the last one in that column? 3x plus 4y equals to 10. Well, that's an equation because that's not always true. And x and y do not represent any specific quantity. So it's not a formula. Okay. So it's an equation. So Q. Let's come to the second column. 3x plus 4x equals to 7x. Well, 3x and 4x together is 7x, which is the same as right hand side, which means whatever value x takes, the left hand side and the right hand side are always going to end up giving the same value, and hence identity. Okay, V equals to L times W times H. Well, as you know, volume equals to length times width times height, right? So it is a formula. 7x equals to 21. We can find the value of x is 3, so it's an equation. We can solve it and find the value of x. That's an equation. So Q. C equals to 2 pi r. Remember this formula? Circumference equals to 2 times pi times the radius in a circle, right? That's a formula. What about 5 brackets a plus b? Well, clearly there's no equal to sign, which means it qualifies as an expression. E equals to mc squared. Okay, that's the famous Einstein equation, but E represents energy and so on, right? So you know that each of them represents a specific quantity, and hence it's a formula. Xy the whole squared equals to x squared y squared. Now clearly xy the whole squared is xy times xy, which is x squared times y squared, which is the same as x squared y squared. So left hand side and right hand side will always be equal. So that qualifies as an identity. What about 2y plus 3z? 12y plus 3z. Clearly, no equal to sign means it's an expression. 2x squared plus 5x plus 7 equals to 10, right? That's a quadratic equation. So not left hand side and right hand side will not always be equal. It's not a formula either. So it's an equation, right? Q. And finally, a squared plus b squared. Now that's easy, right? No equal to sign means it's an expression. So E. Well, I hope you got all of them correct, or most of them at least, right? This was easy, right, to qualify or classify each one of them into each of the four quantities. That's the end of this lesson. I hope you understood whatever was taught in this lesson, particularly what does each of these quantities mean? Okay, expression, equation, formula, and identity. Just to be more specific, expression is just a combination of terms without an equal to sign. Equation is an expression equated to something. Formula is a specific kind of equation where each of those variables represents a specific quantity and they have some meanings like a speed, distance, area, length, and so on. An identity is a special kind of equation where the left hand side and right hand sides are always equal. Irrespective of the value of the variable, they will always end up giving the same answer. Right? I hope you enjoyed this lesson. See you in the next lesson. Bye.